Welcome to today's webinar, TWM1 and Next Generation AC Input Light Engines. I'm Carrie Meadows, Chief Editor of LEDs Magazine with Endeavor Business Media. Thank you to ERP Power for supporting today's presentation. Make sure to submit presenter questions or contact our webinar specialist with any technical concerns using the Ask a Question function on the left side of your screen. Please turn off any pop-up blockers in your browser for the best experience. All registrants will be notified by email when the webinar is archived for on-demand viewing. Also, check out the Event Resources menu below the question box for more information and the slide PDF. Today's speaker, Vacek Javadian, serves as Vice President of Applications Engineering at ERP Power. Vacek is going to share a demo video later in the presentation, so stay tuned for that. Welcome, Vacek. The floor is yours.
Thank you, Carrie. First of all, thank you everybody for attending this webinar. I know everybody's busy and we have a jam-packed presentation. And you're going to see some of the presentation be sort of a refresher on TWM2, although this is about TWM1. The main reason is that functionality-wise, they are very similar, and I'm going to focus on basically what functions are the same and what the differences are and where each one is going to be applied and what application works the best. So with that, let's tighten your seatbelt, have a jam-packed session again, and I hope this will be helpful for you guys. Both TWMs are very innovative designs, and they are highly integrated light engines. And TWM basically comes from Tunable White Module. That's the abbreviation of it. And think of it that there's a 3-channel AC driver built into the light engine. So it's basically AC input. It's universal voltage, 108 volt to 300 volt AC. And then it is tunable. Tunable meaning that not only you can select ANSI standard CCTs, you can dial into any CCT that you wish. Let's say somebody may want to have 3250, whatever, you can do any CCT. Basically, it is tunable to any CCT that you wish. Also, it supports warm dim modes. There are 2 warm dims already programmed there. One is halogen, another one incandescent. Halogen range is from 3050 to 1800K, and incandescent is from 2700 down to 1800. On top of it, you can select the lumen output. And you know that certain times you install the fixtures and then people may want to have higher or lower lumen, maximum and minimum. So you can select the entire range, configure it, program it, and I'll go through all of that later on. It is dimmable with 0 to 10 volt, triac ELV, and we call them tri-mode. Pretty much most of our drivers are tri-mode, and so are these modules. Tunable CCT, and as we talked about, but the key point is that the CCT tuning is done by 0 to 10 volt dimmers. So just keep that in mind. That is the only type dimmer that you can use to control the CCT. Also, these light engines are very high, the quality of light is very high, so 90 plus CRI and R9 plus 50, 2-step, typical 2-step macadam ellipse, although in the spec we say 3-step, but in reality they're around 2-step. And all the parameters within the device are configurable. Essentially, the CCT, lumen, warm, dim, dim to off, any feature that this part has, it is configurable. And the way it's done, either we do it with the programmer, and we'll go through that, or the Bluetooth app. And essentially, that is the Bluetooth commissioning. So it's a Bluetooth app commissioning that we'll go through in a lot of detail in the demo section. But most importantly, one of the main advantages or one of the main features about this part is that it gets rid of the obviously the driver is already embedded and gets rid of the J box, and it is very easily replaceable in the field because it is top mounted. So you can think of it as a light bulb. So you just plug that in, light bulb, and as you know, if things are already mounted and it's mudded, it is very difficult, sometimes not even, you can't have access to the driver, and it's a big fiasco to get back to the servicing the fixture. But in this case, it is top mounted, as I said, just treat it as a simple light bulb. Also, we provide the Bluetooth and non-Bluetooth version, so if somebody doesn't want Bluetooth, so we take that out basically to lower the system cost. And we offer with and without the diffusion. So again, I'm going to spend a great deal of time on the optics, and we'll go through a lot more details there. Circadian rhythm, by the way, it is trademarked, so we're going to use something else, and this is going to be supported. We're already working on it. 90+% of the hardware and the firmware is already there, and we're going to be supporting it in the next release. Dimming range, 100% to 1%, as I mentioned before, dim to off, and then dimming trim also is supported. Dimming trim meaning that you can set the minimum and the maximum to whatever you want. So let's say you can have, I don't know, 14% to 78% range, and then your dimmer will work in that range. And then there's the onboard thermal foldback as well. In terms of compliances, UL, CB, so these are, all of these are going to be supported. We are already gone through and going through the UL and everything else. So I'm not going to spend more time in there. So bottom line about all these features I talked about, what is the benefit to the user? Number one, it lowers the system cost dramatically while offering a high quality of light. That is the biggest thing. And in some cases, the system cost or the module cost is roughly or somewhere in the range of what you pay for a, let's say, decent driver nowadays. So think of all the features and everything at the cost of a driver. Minimizes number of SKUs. This is the most important thing. As you know, major lighting companies, they have God knows how many CCT, how many lumen output, or other features as well, dim to off version, Bluetooth version, whatever. If you think about the number of SKUs is mind-boggling. So all of these can be supported with a single module. And most importantly, it simplifies the fixture design. So it is a very simple, quick time to market type of a solution for fixture designers. And as I alluded earlier, the field installation and support and serviceability, it is dramatically improved and simplified. So it essentially reduces the cost of installation and servicing in the field. And example of applications, by the way, these can be used in a variety of applications, but these are some examples. General illumination, namely downlight, more of, let's say, TWM2 application, architectural lighting, track lighting, accent lighting, more of TWM1, where you need to be fairly small beam angle, and also physically needs to be small for, let's say, tubular type designs. And both of these parts, in essence, you can think of them as three separate modes of functionality. One is static mode, another one is tunable white, the third one warm dim. So we can put the part in three separate modes. So in order to put them static mode, meaning that it's going to be a fixed CCT, let's say somebody wants to ship only, let's say, 3,000 CCT or 2,700 CCT, you can put any one of these. And the way you do it is by leaving the CCT inputs open, and then it can be configured, and then the part becomes a fixed CCT as you have your existing fixtures. Tunable white mode is when you connect the CCT dimming lines to 0 to 10 line. Essentially, by moving the dimmer, you can slide through anywhere from 6500K to 1800K. So that becomes your tunable white mode. And one more important thing is that I think I briefly mentioned it, but it's super important, that the CCT only can be controlled by 0 to 10 volt, while the intensity you can control it by 0 to 10 triac ELV dimmers. So there's a slew of dimmers that support that. Now, warm dim is where, as I earlier talked about, so it essentially goes through, let's say this is for mood, or let's say later at night, you don't want to have the blue content, you don't want to go high CCT, let's say 4,000, 5,000K. So this will support from 3050 to 1800, or in incandescent mode will be 2700 to 1800K. And the way it's done by shorting the CCT lines. So this is like forcing it into warm dim mode, but for all practical purposes, I suggest that not to do this, because once you put it in this mode, then it's hardwired, and in the field, you're not going to be able to update it by Bluetooth or programming. So again, these are some app note things, topics that I have it in our technical document that we share with our customers. So now this is a photo of all of the, let's say, standard ANSI CCT. So I just took a picture of it inside the sphere, kind of give you an idea what the range is. Again, this is by a regular, this is a regular photo, so may not be exact, but as you know, there's some cell phone picture taking artifacts involved, but it kind of gives you an idea what the CCT range is. And also the intensity, pretty much the same thing, going from 100% to 1%, or you can go into off, totally off. Okay, now this section, I want to cover two topics. Number one is that we get a lot of questions, what kind of LED you use, and then I want to most importantly compare TWM2 with TWM1. So first of all, we could use any kind of LED you want, but the first shot of, or the first options that we went with TWM2 and TWM1 are 3 desaturated color LEDs. I'll talk about more and I'll show you the gamut later on to be more specific, but just think of it as a 3-channel with 3 different LEDs that are not on BBL. Think of it as above and below BBL, and we dial in with the different percentages of current to make sure that we get the exact CCT that is desired. So that's how they work. And some other modules where actually there's color, we use other types of LEDs like the high power color LEDs, and again, I'll spend a little bit more time towards the end. And the way that we keep the LPW or the efficiency high is by driving these LEDs at a low current, and so that gives us fairly high LPW, lumen per watt. And then most importantly, the thermals are pretty good. So if the thermals are good, meaning that you're going to have a reliable system and you're going to have less of depreciation in color and color shift as well. So now let's get back to comparison of TWM2 with TWM1. So TWM2 was the first one we introduced, and that's a 32 millimeter LES. As I mentioned before, more of like general illumination type applications, namely downlights and similar type applications. And the puck itself is about 65 millimeter, and it puts out about 2,500 lumen. That includes the diffuser. Now with TWM1, it is more geared toward tighter beam angles for more architectural applications, and that's why we offer 9 millimeter, 12 millimeter, and 19 millimeter LES. And the puck itself is fairly small, 50 millimeter. So 50 millimeter is slightly less than 2 inches. So you can think of it that this can fit into like tubular type designs and smaller architectural applications. And most importantly about the TWM1 versus TWM2, which is a fairly big difference, is that TWM1 is ZAGA compliant. And what that means that you could use vast array of optics holders coming from well-known optics companies like Lidl, Leblink, and Gagion, and you name it. So that is a big plus, and as I said before, I'm going to spend a good deal of time in the optics because, especially for TWM1, that's a critical part of the design. So now, in a nutshell, TWM2 and TWM1, they replace essentially your LED. It could be COB or an LED board, metal core PCB, driver, J-box, diffuser, and depending on the design, a whole bunch of other things. depending on the complexity and controls that you might have. And then on top of it, it offers all the other features that it has. You know, let's say if you use a COB with a standard driver, one channel or two channel driver, you're not going to have all these features like programmable CCT, programmable intensity, tunable wide, warm dim, dim to off, tri-mode dimmable, Bluetooth commissioning, circadian that is coming up. And also, you can't get this compact design. I mean, we're experts, ERP. We've been doing very compact driver, basically power density. It's the highest in the entire industry. So we pushed that limit in TWM2 and TWM1 as well. And you could see that in, let's say, 2-inch diameter and, let's say, less than an inch height, we can pump out a lot of light out with a lot of capabilities that it's unheard of in the industry. So that's where the innovation comes from. So the benefits, again, pretty much the same thing that I talked about: lower system cost, minimizes number of fixtures, simplifies fixture design, and field configuration and serviceability, just like a light bulb. So these are the same benefits. So as I mentioned a minute ago, optics support for especially TWM1 is very critical, but in TWM2 as well, because the LES is fairly large, or compared to TWM1 is large, most of the optics or the secondary optics that is going to be used in TWM2 is going to be some sort of a reflector. So we had to build some adapters, basically we call them like holders or adapters there. And we went ahead and designed these for ladle type reflectors. For in this particular one, it's Angela and Angelina, and it covers the whole family, like the spot, medium, and also wide. And we have a part number, you can order it. So, I mean, there's a whole bunch of them in the market as well, but these are the ones that meets and it adapts to the holes that it's already on the puck. So this is TWM2, and as you can see, the same screws that we use to mount the module to the heatsink, now it mounts the reflector, the holder, all at the same time. So it goes through and mounts it to the bottom heatsink or the chassis, whatever. And to give you an idea that, you know, these are real pictures, real stuff that I did for one of the shows, and these are some examples. Again, nothing earth-shattering, but we're already using those adapters for holding the reflector, and these are Ladle and Nada. Again, just a quick view of Angela and Angelina and the Nada. So anyway, let's not go through too much detail. So one important key point about the option that I just mentioned a minute ago, that we offer these modules with or without the diffuser, is that obviously when you use with diffuser, it's a complete puck. You don't have to, I mean, you could, but you don't have to put any other optics on it, depending on if you want to do any wave shaping or not. So as you can see on the left-hand side, it looks pretty nice. But if somebody selects not to use the diffuser, just keep in mind that the reflector is like a mirror reflector, and that is not going to do much of a color mixing. So whatever optics that you use, or any customer that wants to use it, they have to have the color mixing there. And that most possibly is going to include some sort of a diffuser to do the color mixing. So some options would be using like a wide optic reflector. As you can see, if you add just the reflector alone, there's huge amount of color mixing. So again, I don't want to make this a optics session, but I just want to quickly, mention that, you don't run into surprises that hoping that without optics everything's is going to look good first shot. So without optics means that the user is going to put the optics in there to do the color mixing and a wave shaping and a beam angles and everything else. Okay, so in TWM1, as I was talking about, TWM1, it is more of a narrower beam applications, but not necessarily, but it's capable of doing much tighter beam angles. and the LES is small. So in TWM1 applications, most possibly customers would be using some sort of a lens, most often some sort of a TIR lens. And the lens reflector, whatever mounting capability with Zaga holders, so that is one option. And then, as you can see on the left two pictures that I have here, I call it Zaga lens holders, and these are the Lettel ones. Actually, this happens to be Hekla from Lettel. The center one is what we've done for some customers that they want to use their own or their own holder, or use an off-the-shelf holder with a some sort of a custom optic. So basically, we put the notches there. I call them like twist and lock mechanism, and this is pretty much most like reflectors. They do that. Nothing earth-shattering. So instead of having the top basically flat, the top plastic has the notches there for mounting some sort of optics and most possibly a lens. As you can see on the right-hand side, those greenish ones, so you could have some sort of a holder, either standard optics from Lettel, you name it, or you can do your own custom optics, which some of our customers already done. So again, I mentioned Lettel, so there's a ton of them. And by the way, I mean, I have these optics myself. So Yasmin and Amy, these are the good ones that it's going to fit to Lettel, the TWM1. And I mean, these are the optics that I've, as I said, I had it from my good old Cree days. And so I tested them out using standard holders because, as I said before, these are Zaga compliant, so the same holes I was able to use on the TWM1. So to kind of show you, by the way, this on the left-hand side, this is an optics from one of our customers. It's a little optic that they had along with a Zaga ring there. That's the optic holder there. So I just want to go through the simple process. We didn't have to do anything because, again, these are Zaga compliant. So I'm showing the bottom of the optics there on the lower left-hand corner. At the center top, essentially that ring sits on, let's say, the 19 millimeter TWM1. So the same holes match, again, because it is Zaga and it matches with the holes on the heatsink. So all we got to use is use the two mounting screws that come with the TWM1 and mount those holders, and then click and twist the optics, whatever in this case is a larger one. You can do any Zaga compliant optics there, and you can basically twist and lock, and voila. So I mean, I did not have anything to do with this, and one of our customers had this, and I just tried it in 2 minutes. Boom, we have a fixture that puts out a nice, decent light out with a good distribution. Okay, so on the 12 millimeter one, so this is a custom one that, as I showed before, so the top of the TWM1 has these notches and for twist and lock, and this is actually a custom design that one of our customers already had this design with the optics and the holder. So essentially just, plop it in there with these and then twist and lock, and boom, you got the fixture with a very decent optics. By the way, we are designing a series of optics for TWM1, and these are going to be like a general purpose, but smaller than, let's say, some that are available in the market. So somewhere in this range, size-wise, but although most of the Lettel ones and stuff are, very good in performance, but some of them are larger. So for customers, they want the absolute smallest ones performing, let's say, spot and mid-level light distribution patterns. So we are coming up with some optics again. It's not, we're not an optic company. We don't, that's not the purpose, but we want to have some options for some customers. Number one, the ones who do not want to develop their own and want a certain performance, they can go ahead and use it, or this would be like an example what can be done. And then this is the optical pattern, again, without doing much. This is based on our existing customer's design and looks very decent with TWM1. Okay, just a quick thing. As I mentioned, TWM1 comes in 9, 12, and 19 millimeters. So this is the 9 millimeter one, and this kind of show you the sophistication of the board. So in this little puck, which is 50 millimeters, less than an inch height, I mean, there are 2 levels of board that goes inside, and that's all. I'll just leave it there without going into too much detail. So the programming, as I mentioned it, you can configure these pucks, both TWM2 and 3, which I'll talk about later. Essentially, there are 2 8-pin, or you can 8 digits, you can think of it, dip switches. And based on the value of the dip switches, you can program the entire module. So to show you what are the options, and by the way, this is printed on the back of the programmer as a cheat sheet you can look up. So remember I was talking about the fixed CCTs. You can program any of the fixed CCTs, and then the warm dim at the left hand side at the bottom, so you can select which one of the warm dim profile you want. And then on the right hand side, you can select if you want the full 100%, 80%, 60%, 40%, or again with the same intensity variations along with dim to off, or along with the DLE enabled or disabled. So you can see there's a ton of options, and each one of them can be configured with a programmer. But as I mentioned before, these are the standard, let's say, ANSI CCTs, or fixed, let's say 100%, 80%, 60%, 40%, let's say lumen intensity. But you can use the Bluetooth app that we'll go through in a lot of detail in a few minutes, and you can set anything in between. So these are, as I said before, we're just going with some standards that most people use, but if you need more granularity, you're going to be using the Bluetooth app. Okay, so thermals are very important. Again, I didn't want to do a presentation without emphasizing thermals. So we've gone ahead and tested out a bunch of heat sinks. Again, nothing, I mean, we're not a heat sink manufacturer or anything. So off the shelf, we just want to show you that you can, as an example or as a reference, that you can use this and what kind of a performance you'll get. So based on the thermal resistance of each one of these heat sinks, you'll know what you have to do in a chassis if you plan to use the chassis or the fixture as your heat sink. So bottom line is that you could use 70C as your reference. You want to keep the TC below 70C. Obviously, lower TC means that your system overall is going to be more reliable, and obviously less lumen depreciation, but most importantly, less color shift over time. So this is just keep that in mind, that you want to do whatever you can to keep the thermals under control, because these are very small pucks and we pump in a lot of lumen out, and the thermals are critical. You can't just ignore thermals, so it has to be part of your initial thermal design. And by the way, we have a few thermal design app notes on our website and some videos, and I strongly recommend you guys taking a look at it. Although it is not designed for TWM1 and 2, but the thermal concept is exactly the same. Doesn't matter if it's a driver, it's a puck, or whatever. The concepts are exactly the same, and you have to follow the same guidelines. So as you noted, I talked about so many variations and options on TWM1. So I'm not going to go through all these. It's more of an eye chart, but let's say if you want the, what LES you want, there's a bit here that you can select, and this is the part number, and then the lumen output, and then what features you want, Bluetooth or not, and then you want the diffuser or not. But most importantly, we also support TWM1 in both configurations. The wires can come out from the side or bottom. We know in tubular designs, it is very important to have it coming from the bottom. So anyway, also the dimming controls, I mean, we have obviously Bluetooth and 0 to 10 track ALV. Dolly and DMX will be supported later on. We're working on it. Okay, now I want to spend a few minutes about the other, or we call them next-gen TWM modules. namely TWM3. So the standard ones, we have TWM1 and 2 that we covered extensively. They're based on 3 LEDs, as you can see above and below. By the way, I mean, this is a picture. It is not the actual location of the LEDs, but just think of it as a triangle, and then we control it by the amount of drive current, and we dial it on the BBL, as you can see on the curve there. Now, what is TWM3? This is the first time we're talking about it. So TWM3, think of it as a higher lumen version of TWM2. So it's exactly the same, except we pump out 4,000 to 4,500 lumen out of it. So you can think of it, this is for applications that you have high ceilings, I don't know, 20, 24 feet high ceiling. So you can do a downlight or any other fixture for high ceiling or high bay type applications. So this is really what it's designed. And this was based on recommendation of one of our lead customers, so we went ahead and did it. Now, on the other hand, SWM, think of it as a single point. Instead of having 3 channels, it is a single channel, meaning that it's going to have a single CCT. And the whole idea behind it that not everybody needs this 3-channel and all the features that we talked about. So for lower cost applications, let's say somebody wants to do, let's say, downlights only at 3,000 or 2,700, this SWM will be the most cost, I guess, sensitive or the most lowest cost solution out of all the modules that we have. So let me go through another one, which we call it AWM. So now AWM stands for Augmented White Module. So to make it clear for you, think of it as TWM2, which supports the white range coming from, let's say, 6,500 all the way down to 1,800. But then on top of it, you have full color, meaning saturated color. So in order to accomplish this, we need to have 6 channels. 3 channels of the driver is used for generating white, pretty much the same thing that we talked about on TWM1 and 2, and then 3 channels of saturated high power LEDs that we're using to create color. So these are higher end, let's say, solutions for, and obviously it's going to be slightly higher cost than the regular TWM1, but some applications do require color for, let's say, mood, or basically during Christmas time, they want to convert it green or whatever, or some parties, you want to create a mood. So this is what AWM is all about. And you can see on the left-hand side on the 1931 CIE chromaticity chart, so we have the triangle which shows the white, and then we have the large triangle that goes all the way to deep green, deep blue, and deep red, and is capable of producing saturated colors. Okay, so this this slide presents pretty much, I don't want to say evolution, but it shows the progression, how we started and where we're going. So right at the center, the blue section, I call it standard series. So we started with TWM2 and TWM1. Standard meaning is for the general, let's say, illumination. Obviously, the LES on it is like 24 and 32, down to 19 millimeter for TWM1. But then what we did is we went up in capability and down in capability to have a lower cost. So for lower cost, essentially we went to SWM, which I just showed you. It's a single color, single CCT with basically stripped out version of TWM2 and 1. And LES, the same thing, 19 millimeter, 24 and 32. So that is the lower cost or stripped down version. But if you go up, would be AWM1 and AWM2, as I just talked about it. It has the white color and has saturated color. So now going to left is moving towards tighter beam angle applications. Essentially, we provide the same 3 series, TWM1, SWM1, and AWM1 in 9 and 12 millimeter. Essentially, we'll produce a very tight beam angles, and we call them high density series, meaning that essentially higher lumen, per millimeter of LES. That is what these parts are. It's called high density series. And then all the way to the right, we call them high output. As I just talked about, TWM3 can pump out 4,000 to 4,500 lumens out. So that is really how we categorize it. I think this might need a little bit of a time for you guys to look at it and then kind of digest all, but in a nutshell is 3 separate categories, and we can go up and down in each because we know not every application or not every customer, they're going to want one option. So we provided various options for different applications. And again, this is by popular demand from some of our major customers, and that's what we came up with all these different options. Okay, now at this point of time, we're going to go to a demo, and we're going to do a video based on our limitations. So we have a video that will show, and Matt is going to run that in a second.
Hello everyone, welcome to the demonstration of the ERP Bluetooth app. So if you look to your attentions to the lights themselves and also the app I currently have here on the screen. So here's the home page of the app itself. So as you can see here, there's the lights that they show. They're just going to scan again, just make sure they're loaded on there. So you can see all the lights here on the app itself, and you can also see some of the lights that are being displayed in their lights. So for the home screen itself, you're able to see some of the lights that are shown on it. What you can do on them is that you can just turn them on and off. For example, right here, we're going to turn off sample 4 right here, which is going to be unit very light, as so. And then we're going to be doing the same thing with sample 1, and then sample 3, and then sample 2 right here. In addition, what you can do on the home page, in case you would like, is to rename some of your sample themselves. For this function, what you can do is that you can hold one of the buttons here, for example, sample 4, and you can change it to whichever name you like. For example, let's say we want to change it to another sample number, let's say 5 or 6, something like that. We can keep it 6 for now. So we can save on that, and then that'll show on the TM name itself. And then there's also a few functions you do. For example, hit scan here, you can see if there are any other units, but most likely you won't be able to see any of them since we don't have any new devices here at the moment. You can also hit edit right here in case you want to also rename the unit that way, or if you want to, you can forget them as so right here. For now, we're not going to do that function. So for the units themselves, what you can do is that you can change the CC to them either individually or with a group. To change them individually, what you do is that you select the unit right here, and then you'll see the sample that we just named light up itself. So as a bit of a preview of the page itself, you can see some of the features you can use to commission the unit itself, including some of the information here. For example, there's the TM2 name, there's the firmware version, there's the current temperature of it, and there's also the current serial number of it. So what I want to show first is how to change the CST of the unit itself. There's a couple ways to do this. The first way is just using the setting slider here below to change it. So right now, as you can see on the very right, the sample is set to 4000K. So to change the CST with the slider, what you do is that you simply press on here. You can slide up to all the way to 6500 to change up to the highest CST, or you can slide it all the way down here to change to the lowest CST setting available for the TM units, which is 1800K. The other way you can change the CST is using one of the preset values down here. There's some color palettes you can see on here from 1800 to 6500 once again, and you can just select one of these to change the color. In this case, we're going to just change it to back to 4000, so if we press this right here, then you'll see the light change itself accordingly. What we can also do as an example here is change both some of the intensity settings and also some of the trim settings. For the intensity, what you can do here is that you can mimic dimming the sequence with the sample itself. So for example, we can change the light intensity from 100% to 0% here, and then we can also change it back. Please note that this app is not supposed to be used for dimming purposes. Rather, this is just for a commissioning tool, so you can think of this as a preview view like. In order to change its trim settings, you have this toggle on the very left here that you select. This will bring up a couple of brackets, for the maximum and minimum trim. For the maximum trim, if you select this bracket right here, you can change it from 100%, that's its default, to anywhere from, let's say 50% to 100%, like a huge amount. Just for the compensation, we can use 85% as for the minimum trim, or the minimum dimming percent that you like. You can change it from anywhere to a good amount. For example, let's use 10% here. So now we've set 85% as the maximum intensity for this unit, and we can also use 10% as the minimum intensity for this unit. What we can also do is change a couple of the special parameters on the TM2 unit, so including dim to off and warm dim enable. What you can do is that, assuming that you have a trim for the unit itself, what you do is that you select this toggle for dim to off right here, and then what happens then is that when you dim up and down, instead of going 1%, then it turns off, like dim to off. And then if you untoggle it, then you dim up and down with it, then it just goes back to minimum dimming as well. As far as warm dim enable, what you can do is that you select this toggle here, and then you can switch between a couple of incandescent settings. So the default one is just the halogen settings, and if you want to get a bit more into the warm dim settings, you select this warm dim tab that's going to be near the presets. So there's halogen and then incandescent. With this tab on, you can dim up and down in a similar way, except now it's just in halogen mode. What you can also do is switch between either halogen or incandescent for one of the warm dim modes. For example, we're going to switch to incandescent, and then once we do that, then we can dim up down just fine. And then we can also do the same, with halogen. Once you think that we selected all the colors you want, either warm dim, or if you just want to keep a static white mode setting, such as this setting right here, what you can do is that you can save your preset in case you want to save the setting, for later installation sites or other applications. So what you do is that you hit this button that says Save Preset. You can call it whichever you want. For example, we're just going to say, 3500, demo, and then we can hit save on that. And then whenever we need to retrieve it later on, you just click on the saved icon that's going to be on the bottom right of the app, and then we're going to retrieve it from right there. What you can also do is that you can also create passwords, with the TM lights themselves, just to make sure that you can lock the units so that no other user can access them, and it's going to be for your own use. So how you do that is that you're going to select the icon next to the name on the right called lock. You press that, and then we're going to be setting the password on it. For now, let's just call it demo right here. We just enter in whichever demo password we want, which we're just going to literally call it demo, and then we're going to hit set password, and then we get the confirmation that the password has been updated. And now, if we go back to the home page right here, we can see that the light has now been locked and that we can't even control it at all, and we can't even toggle it on and off. That's because the password's been enabled now. And then the same thing with any of these things right here, those aren't able to be toggled now. So now, in order to be able to unlock it again, what we do is that we hit unlock, we enter in the same passwords before, in which it's demo, we hit unlock, and then we just wait for the prompt to show the light has been locked, in which you can see right there, when it's been unlocked, there's a single flash on the TM unit so that we can finally control again. So now, as you can see here, now we can toggle this on and off and resume control again. Now, how to control a single TM2 unit. Now we're going to show how to create a group combining all these units together so that we can control all of them at the same time. So how you do that is that we're going to go to the home page here. We're going to select the icon that says create group here, and we just type in the name. Let's just call this TM2 demo for now. We're going to hit create here, and now you see the group itself. How you add the units themselves to the demo group that we created is that you hold the button or the units themselves, and we're going to drag each of them inside of here, as so. For example, now we see all the samples within the group, and you can see that once we've added the units inside the group, that they've all changed to the same settings now, and now we can control all of them at the same time. For example, if you hit the on and off toggle for the TM2 units themselves, then you can show that they're turned on and off. Now that we've grouped all these together and confirmed that they all can be controlled at the same time, now we're going to change the group settings themselves. We're going to select on the demo group itself with this tab right here. You can also name it and such in case you want to change it to something else. We're going to select the group here, and you see all the lights flash when we select the group itself. The only difference you see with the group page as opposed to the individual page is that you don't see some of the individual settings now, like you don't see the model name, the firmware, and such. Otherwise, all the functionalities are pretty much the same. For example, you can just change the CCT in the same way. You can change the colors from 6500 to 800 and so, and you can see all the lights are changing at the same time. You can also use the preset in similar fashion. You can select 3000 for example, and all the lights will change the same way. Same thing with intensity, as you can see here with these lights right here. Also, if you remember from earlier, we had saved a preset, so that we can treat some of those colors later on. So now we can do, if we just change it to here, then we can go to our save settings in the lower right. We can pull up the demo settings. So we have a few colors that are pre-saved, except this time we're going to be doing the 3500 demo for the 9%. We're going to select that, and everything will change to there. And then just give it a second, and there you go. Now you see that the colors went back to the preset as before. You can also lock all these units at the same time. So once again, if we hit lock here, and then we set the password, then we can give all these the passwords. For example, we can do demo2 in this case. We can set the password, wait for a prompt, and then if we go back to the home page, they can see that all the units now have been locked. Now, in a similar fashion, if we go back to the same group again, if we hit unlock, we can enter in the password we gave these, hit unlock, and then it'll show the same prompt, which the lights will be unlocked successfully. So that's pretty much the summary of it. The only other thing that I'll mention is that if you click on the settings button on the bottom of the home page, there's a few other settings you can change for either the app or the Bluetooth parameters themselves. For example, there's a support tab here, there's also a utility tab here, and there's also a blue tab too, in case you wanted to either show the demo light always, or you wanted to change the discovery distance of the TM2 units. Or if you really want to, you can just select and hit forget all lights. Otherwise, I think that's it. For the units commissioned now, we can simply exit out the app by swiping up like this. That releases the units from the app itself. And then after that, we can just simply dim the units, as they were before. So now they can be dimmed up, dimmed down, with the CO10 dimmer they have attached. And that's about it.
Okay, everybody. Obviously, the demo can go a little bit longer, and then later on you can download it. But most importantly, I'd like to have a section that we can answer the questions, and Q&A is very important, and to me it's a lot more important to address your questions rather than going through the rest of the demo, which you guys and gals pretty much got a good taste of it. So again, these are the benefits, and it's a game-changing tunable white module. and lower system cost, integrates numerous high-end features, eliminates hundreds of SKUs, simplifies fixture design, quick time to market, reduced field installation costs, and serviceability. So with that, let's move into Q&A. Carrie, do you want me to go through this, or are you going to read one at a time? It's up to you.
No, I have the questions organized and in the priority order, what we think we can get to, and I'll just read them off to you so you can answer.
Good.
All right, so our first question from the audience is, will this tunable white module require any drivers, or is the 120 to 277 VAC input direct?
The simple answer to your question is no, it does not need any driver because the driver is already included. The input is AC. You can plug in the wires to AC, 120 volt, 277 volts. Think of it as universal.
Great. How can folks request samples of the light engines, and are they available now?
Yes, so TWM2 samples obviously available. TWM1 is also available. You can get some early samples. You can think of it, TWM1 would be engineering samples. Yes, you can request it from your sales representatives and the distributors that offer our products. I think that's the best thing, or you can directly call our office and we'll get you a sample.
Great. So this is an interesting question. Is there any DMX option for TWM2 or TWM1?
Yeah, we are working on DMX on TWM1. We don't have it out yet, but that is being worked on as we speak.
Okay. Are you able to stay on the black body line when tuning from 1800K to 6500K?
Yes, that is actually one of the reasons that we use the 3 desaturated colors. As I don't know if you can still see my screen, so I'm just going to go to this page. Carrie,
yes,
is my screen still on?
Mm-hmm.
Okay, very good.
Yep.
Well, as you can see, we're magnifying the BBL, and there's this triangle. And so think of these dots there at the corners. Each one is a LED that has that particular color. But again, I mean, this is an artistic, let's say, drawing. In reality, different. So because we used off BBL, and this is where desaturated comes from. Saturated means that unlike our AWM color LEDs, these are still considered color, but they're off BBL. There's, let's say, the green is like greenish hue, the red is, let's say, light pink, the blue is, let's say, sky blue or something like that. And then we dial in, we're using the combination of these 3, we dial in exactly on BBL. And as I mentioned before, we can hit it with two-step macadam ellipse. I don't know if you're familiar with that. Essentially, it is very tight that most people cannot distinguish the difference. It's most often any lighting modules or even LEDs, they typically offer like 4 steps. I rarely see anything better than that. And so we can hit 2-step, which is very tight on all the CCT standard CCTs that we talked about. And that is part of the design of the module. By the way, since you asked that question, we do calibrate each one of these modules during manufacturing and make sure, because as you know, each LED is slightly different. That's why on the CIE chart of each LED, they're not going to be exactly the same. We get, let's say, thousands of LEDs, although they're going to be pretty much the same bin. But even being within the same bin, they're going to be within like 4 steps each, and then we have 3 of these, so they're never going to be exactly the same. So in order to make sure what you're asking for, to assure that all of these are going to be exactly on the BBL, we do go through a calibration phase during manufacturing. So that is how we guarantee it. Yeah, yeah, that's great. That's thorough. How about comparison to the CTM1C in cost? Okay, I'm not cost person, but I'll just give you an idea since you asked. So CTM1AC, think of it as a very high-end module, and it is designed for high-end, much higher cost applications, while all these TWM engines are designed for low-cost, high-quality type applications. And for that matter, the cost of all these TWM modules that I talked about, TWM1, 2, and 3, it's going to be a fraction of the cost of the CTM1AC module. And for the exact figures, I'll talk to our sales people, but it'll be CTM1AC will be multiple times more expensive than any one of these modules. But again, we'll get you in touch with our salespeople to give you more exact answers.
Great. What about the app? Is it available for Android?
At this point of time, the first cut of it, we've done it for iOS, so basically Apple devices, Apple iPhones and iPads and things like that. In the future, we might do it, but for all practical purposes, we're going to make a lot more changes, and we will do probably a ground up. But the simple answer to your question is no, it's going to be iOS, at least for the foreseeable future. Just let me tell you that it's a tremendous amount of work just to support the iOS, and I myself have been basically leading that. It is extremely time-consuming to debug and make sure all the features work. And as you saw in the demo, which was a partial of the small of the capabilities, there are a lot more capabilities there. So again, for now, as I said, for the foreseeable future, we're going to stick with iOS, and on the next rev or even on the next hardware rev, use most possibly different Bluetooth chips. So again, I'm giving you more than you asked for. At that time, we'll consider developing for both. This cut of it is going to be iOS only.
Well, I think it's important to recognize that those things are complicated, and there's a reason why you're focusing on the iOS opportunity right now. Let's see. Is there also a plan to have a software or an app for controls aside from commissioning?
Okay, that's a very good question. So actually, I have a technical presentation about this. It was more of an app. Did it as a presentation because nowadays people don't read app notes. They like PowerPoints better. So in there, actually, the first page is exactly that. So this, as it is not meant to be a control app, although it has all the capabilities of being a control app. But the target was only commissioning. But as I said, since I'm like very, very deeply involved, more than that I'd like to, maybe, it could be used as a control as well. But again, officially, we consider this as a commissioning app. And again, just like part of the previous question, when we go to the next phase or use a different chip, I'm not going to comment on that, but we're going to most possibly use another microcontroller Bluetooth chip. In that time, then we'll consider that because, as I said, that's going to be more of a ground up develop. We'll consider doing it as a control app and also commissioning. But again, you'll see, by the way, these are going to be, one more thing since you asked about it. So the current version of the app, we've done tremendous amount of changes, and basically what you saw on the demo, we're going to be having a major release, and in there, basically you'll see that, you can download it and you can play with it, and you'll get the feel that this could be actually a real control. But one thing in there that we didn't get too much in the demo is that you have security controls. So let's say in a household or an office, so the office manager, or in a household, let's say the parents will have control on setting the light, and then basically setting a security password. And this is one of the things that I worked on, basically, you know, setting the state machine and all that stuff. So it's pretty sophisticated. So you can set passwords such a way that nobody else, somebody walking out in the street cannot have access to it and messing with it, including your kids or neighbors or somebody in the office, let's say, will not have the control to change the light intensity, colors, dimming, whatever that might be, unless the building manager allows it or whoever the guy sets the password. So all of these are already built in. As I said, they're like, it does have a lot of control features also built in. So again, I don't want to give you guys headache, but since you went there, I want to that you asked for. Yeah, go ahead.
No,
Next
actually,
question.
I don't find that headache-inducing. I'm a little bit shocked that someone didn't actually ask a security question, because that comes up quite a lot in a lot of webinars. I think we have time for one more question. Is 347 volt available for Canada?
We haven't done that. I mean, not at this point of time, because that would just take a totally different driver design, the magnetics and stuff. And as you know, this is a very small puck. I mean, the height of TWM1 is less than an inch with 6 driver channels. I mean, you can think of the technology that it's in there. And simple answer to your question is no, because the size of the market is not large enough. But in case you want us to work on it, all it takes is a large PO, let's say 2 million pieces or something, we'll jump on it right away.
I can understand that. I'm sure there might be other more detailed questions about potential functions, features that you haven't talked about here. You might get some inquiries after the presentation.
Yeah, if there's any questions, I'm not sure if I understood, but if there's any more questions, definitely you can shoot. And also let our distributors or our sales channels, whatever you're comfortable, will come to me, and I'll be glad to answer any questions.
Great. Well, we have hit the top of the hour, so that will wrap up what we are able to cover today. For the audience, do note that our speaker and the team behind him, they will receive all the other questions that you asked, and they will take a look at them and potentially reach out to you individually to answer some of those questions. So again, I'd like to thank ERP Power for making this presentation possible today, and thank you also, Vacek, for giving us your time and covering a range of configurations that can accommodate advanced luminaire designs.
Thank you. Thank you, everybody.
Thank you also to our audience for spending your time learning with us. Thank you, and have a great rest of your day.